All right, good morning, everyone. It's 9 o'clock, and we're ready for Gilad Bracha talking about dynamically typed languages on the Java platform.
Okay. Thank you very much. Thanks to Microsoft for inviting me here into sort of behind former enemy lines, and especially thanks to Eric, who is doing his subversive thing. So this is about supporting dynamically typed languages on Java. So this is the only talk that's irrelevant to the title of this meeting. But the actual content seems to fit very well with some of the stuff we've been hearing. And this is not about so much what already exists or the kind of work people are doing. I'll mention a little bit for implementing dynamically typed languages on the Java platform, but more about making the Java platform a better place for these languages. So a few words about freedom of choice. This is a quote, a partial quote. Some of you may be familiar with it. Any customer can have any car painted any color that he wants. So we can note that this is ever so slightly sexist, but when you see who said it, you'll realize that that's the least of his problems. This was said by Henry Ford, who had lots of opinions about a lot of people, said this about, I think, the Model T. Basically, in the interests of efficient production, he found it much better to just standardize on one color and have everybody run it. And after all, it didn't affect the functionality of the car, so why would they actually want a different color? Now, the reason for this quote is that arguably the situation on mainstream computing platforms is somewhat similar. So it's been said by some that say, Java is like that, right? And you can interpret this any way you want. The interpretation I have makes it clear that it doesn't actually matter that much if it's Java or not. And it may be unfair, by the way. I don't know if it's anonymous or malicious. They're twin brothers who said that. But in fact, I'm willing to take credit for this one. And basically, the issue, while of course this is a deliberately strong statement, and we've heard how people do implement other languages on .NET, and they do that on Java as well. The fact is that it is inordinately difficult. And the reason for that is that these platforms have a model that is the preferred model that fits very well with number one language for that platform. And if you deviate from that, you find it very difficult. The platform does nothing for you, and in fact, does a lot to hinder you. And we'll discuss that. So in a way, this is people want to program in different stuff, and this is about making the Java platform a bit more friendly. So if we go back from the C# interpretation to the Java interpretation, we want to fix that perception and whatever underlying reality that might have given people that impression. So it has come to our attention that some people want to program in things other than Java. Officially, of course, we claim we never said anything different, so I won't claim that we said anything different, but I've had 10 years of arguments with people explaining that this cannot be the end of programming language research, and you might as well look at other things. And finally, people have come around to the idea that perhaps someone somewhere might want to do something different. And so we'd like to improve the support for that. And why would we like to do that? Well, it actually might be useful for some tasks to use a different language, whether it's gluing different, Java tasks together, or building GUIs in an easy fashion, or all kinds of things. And of course, we'd like to broaden the community. And what does broaden the community really mean? Go back. Yes, this is what it means. So, Michael, yes, the answer is we do not have an internet connection on this cable at the moment, but apparently still got it cached. So, of course, we want the community to use our stuff, which is, you guys here know a lot about this particular problem. So, back to our regularly scheduled program. what specifically are we proposing to do about this? A variety of things, from the more definite to the more hopeful. One thing we're pretty solidly committing to doing is adding a bytecode called invoke dynamic. Another thing that I think we will end up doing, at least to a certain extent, is improve support for hot swapping, where hot swapping is a slogan, a short term I'm using for reflective program update, the ability to change programs live on the fly. Since I'm not aware of a concise standard term in the literature for this, in fact, the coverage of this whole topic in the literature is fairly sparse. We're going with this term hot swapping that is short enough that Java programmers will be able to pronounce it. And all of this is part of an initiative. We have this wonderful thing called the Java community process, whereby the community, the guys we wanted to take over just in the other slide, they can participate. You know, we get academics, we get big corporations. Most of the big corporations in the computing industry, except one whose name I forgot. But generally, we do get a lot of participation from different people. And then we start up these things called Java specification requests, which are basically committees that go and meddle. And there's one called JSR 292 that it is my misfortune to lead, that is supposed to figure out, you know, the reality behind this. Though right now, these are pretty much initial ideas. So what is the goal of JSR 292? Of course, as Eric said yesterday, I'm not a goal-oriented person either. And I certainly don't want to commit to any goals, because then, you know, people get disappointed and angry and it's unpleasant. But it would be nice if we could get to the point where a lot or possibly all of these scripting languages could be implemented, quote, natively, rather than build very elaborate structures that either there are interpreters or they're interpreters being compiled into a data structure, which is what we heard pretty much yesterday. Maybe you can do the direct mapping, and then the JVM will do all kinds of stuff, because ultimately very few people have the resources that have been poured into these platforms. The amount of work that's been done on garbage collection and JITs and optimizations and so forth. The average scripting language doesn't have hasn't the time, the resources, the expertise really to do all that for every scripting language, and it would be nice if people could leverage that in a better way than they can right now. Because right now it can be done, but as we heard yesterday, it's pretty convoluted. I need to thank John Goff for going into that, setting me up by showing you what it involves to get some of these languages running on such a platform. We hope that as a result of that, we'll get more implementations of these languages that people can actually use on our platform. And eventually, I don't think this will happen immediately, but over time, as these features get in and get optimized and better engineered, the performance potential of these things is really awesome. I mean, it's far beyond what most of these native scripting languages do, because you can get enormous performance out of a dynamically typed language, but the ones that are widely used here aren't there yet. And some of them are very, very far away, like Ruby or JavaScript, things like that, where the potential is positively, performance is positively pathetic. You can get orders of magnitude. You can easily get 10 times the speed of Ruby without much work, and you can probably get 50 or 100. And that's also somewhat true of JavaScript. So this will take time, but that's sort of the fond hope. But I'm not promising anything, because I'm used to seeing things I work on for a long time disappear, or anyway. So the fact is, people have done other languages on the JVM. So Jim mentioned Jython yesterday, and indeed this slide dates from last fall, so I didn't put it in just for him. It is right up there. Kawa was a scheme implementation, or is. Groovy is a language that a bunch of people are putting together explicitly to be a scripting language on the JVM. ECMAScript or JavaTM script, or whatever you want to call it, right? Mustang, which is our next release that'll ship later this year, comes with JavaScript implementation packaged in, and there are probably all kinds of others. But it's hard. Why is it hard? Well, actually, it is easy as long as you do a single inheritance, single dispatch, statically typed, object-oriented programming language. These platforms work perfectly. The funny thing is, well, if you wanted to do that, well, sure, there are probably a few old diehards like me who might think, oh, I could use Oberon or Modula 3, and those would probably work out. But really, why would you want to use any of those things? You already have a language that is pretty much the same or better and does all this stuff. So the odd thing is people want to use a different language because they want to do something differently. And if they want to do something differently, well, they should be branded and put in a penalty box. Basically, all the scripting languages pretty much are dynamically typed. Most of them have different versions of multiple inheritance or mixin-based inheritance in different forms. And as you've seen yesterday, this can be challenging to do well. So what are we going to do about that? We'll start with method invocation, because that really is fairly central to the kind of languages. I mean, some of them didn't start object-oriented, but they've all incorporated object-oriented features. Some of them are object-oriented languages. And so method invocation is pretty much the central operation in object-oriented languages. So the JVM has 4 bytecodes that are used for method invocation. Invoke virtual, as you might guess, invokes a virtual method on an instance. In Java in particular, all methods are virtual. All instance methods are virtual, and I'd argue that anything else isn't a method, but a static method is an oxymoron. But anyway, that's what invoke virtual does. Invoke interface is used to invoke interface methods on interfaces when you don't know the specific class that you're invoking it on. Then there's invoke static, which oddly enough invokes so-called static methods. And invoke special, well, guess, it invokes special methods, doesn't it? Actually, it's used for constructors, and you can use it for private methods since they actually, you can basically bind the call statically. So we're really going to talk about invoke virtual. So the general form of invoke virtual you see here. You need to tell it what class you expect to find this method in. And of course, it can find it in the superclasses, but this is used for dynamic linking. In the link phase, you'll basically look up this class, possibly load it dynamically, find that it has a method matching the method descriptor that's given in here. This is, of course, an abstract syntax. It's not the real format, but this is what it amounts to. And the method descriptor will give you the name of the method, the types of the arguments, and the return type. And you'll find, oh, yes, it has such a method as the caller expected, and you can do type-safe linkage, and you can basically bind it to, say, a vtable slot, and you can do the dynamic dispatch at runtime. So this is very close to Java programming language semantics, oddly enough. And there are some things that the Java programming language does that this doesn't do. Overloading gets resolved by the compiler. Type inference for generics gets resolved by the compiler, and but the actual semantics of the lookup, the whole lookup is done by the VM. So this is single inheritance, single dispatch, statically typed, and that's really, this is where the real problem lies. So because it's statically typed, we can verify that these calls are correct, type correct, and we have a verifier, and it will do that, and we have told the world how wonderful that is. This is where the trouble begins, and here my troubles began. I don't know how many people are familiar with Art Spiegelman's graphic novel Mouse. If you're not, it's a good thing. I always try to put at least one book recommendation in a talk so that there's some value in it. In any case, in our case, I don't quite mean to compare the verifier or type checking to the Gestapo, and yet the analogy cries out. So the particular problem this causes, we'll see, but generally I said this at Fool to an audience of theoreticians and didn't manage to insult them. I'll try my luck here. Typed assembly language is the stupidest thing in the history of programming languages. Putting this stuff in the root of your system ties you every which way and causes all the problems that I now have lifetime employment to try and solve. So if you look at this, this is sort of a toy snippet, which isn't very realistic. I mean, it's not the way you'd code this thing, but it illustrates the point. We have a new size method. It's supposed to take a collection C. Of course, we don't know that because nothing says it's dynamically typed. Nothing tells you that it's a collection. And the way it does that, it looks at the current size of this thing, multiplies it by a growth factor that is also an attribute of this thing, and computes what the new size of this collection should be when it's full or something. Okay? So how would we go about compiling this given what we've seen? In particular, how would we say try and do the purple call? So it turns out we can write an invoke virtual, and we'll tell it what type to look it up. That's the type we don't know. Since it doesn't have any arguments, that's simple, and then we'll tell it what return type it should bind to, but we don't know that either. And so, in fact, in a dynamically typed language, we can't do the direct mapping. We have none of the information that the bytecode expects, because the bytecode was designed with a statically typed language in mind. So, it's rather hard to do any kind of direct use of the method invocation mechanism. How do you do it? If you can, make, say, growth factor part of some known interface, then you can use an invoke interface instruction and say, go look at that interface, find growth factor, and maybe it'll just return object. And we'll figure out what to do with that later. Whoops, I think I skipped something. Or else I deleted the slide by mistake. Yeah, I deleted. Oh, here it is. Sorry. So it's on this slide, actually. I thought it was on a different one. So one perverse thing that some people have done, you can start making these synthetic interfaces all over the place. Essentially, for every method definition, for every method name at least, an arity, you create an interface that has such a method. You don't particularly care what types it takes or returns. You just make everything an object. And then you cast to, whenever you see a method name, you cast to the interface that contains that method name. And so you have, you've got the interface that has growth factor. You cast to that. It has a growth factor. Star probably represents some sort of encoding of an add multiply method. So you cast this guy to that. And then you cast the result or something. This gets out of hand very, very fast. It's really ugly. The alternative is basically rewrite your own interpreter. And despite the claims made yesterday that, yeah, it's compiled and whatever, you've encoded sort of an interpretation scheme into your system. You've got, dictionary somewhere, and you have a scheme for calling a static method that looks it up. You've done a clever encoding, but really, the VM is not doing this for you. Your data structure is doing that. And this is not optimal. Depending how clever you are, you can get pretty good results, especially if you're comparing to a lot of the native implementations out there that are also extremely suboptimal. So, I hope we can do a whole lot better, because I know you can take a language at this level of abstraction and run it, say, fairly reliably at half the speed of Java or C#. That's been done with Smalltalk, and these languages aren't that different, really, most of the time. And you can't rely on Moore's Law anymore, of course, so you'd better find something better. Or you'll keep it in a niche. So Ruby's famous for Ruby on Rails. They found an IO-bound application, so it doesn't matter that it is the slowest thing I have ever seen. But it's actually, the language could be quite expressive for a lot of things, because it's really a Smalltalk with an ugly syntax, and you could do a lot of stuff with it if it actually was, implementation was more capable. And that's sort of what I'm shooting for here. So there are lots of parts of the solution. This specific piece we can solve relatively easily, basically by mostly by relaxing the typing constraints on invoke virtual. So we introduce a new bytecode called invoke dynamic, which mostly has a different type rule for the verifier. There's a bit more to it, because there's always a bit more to it in these systems. Nothing is ever actually elegant and simple. But it is a loosely typed invoke virtual, and you don't insist on knowing what the type of the target is statically, or at least some known supertype of the target statically, and you don't insist on having the actual arguments be statically known to match the types in the method descriptor. So that gets rid of, for example, the need for all these interfaces and casts and whatever. And you can write something like this. You don't really care what the receiver type is, and sure, it can return object. It really doesn't matter anymore. And if it had arguments, it wouldn't matter what the argument types were. You might ask why I even write this, given since I don't care what these types are, couldn't I just get rid of growth factor? There are a couple of reasons to keep this stuff around. One is simply that the existing bytecode format will actually end up having an index into the constant pool, which will point at a method descriptor anyway. So unless you want to complicate the format with an already complicated format with more extraneous junk, you might as well use the existing format. But there's also another reason, and we'll get to that very shortly. So we said that we're not going to insist that the actual arguments are statically known to match the method descriptor. Well, again, another fact that has come to my attention is that people make mistakes. No one in this room, of course, but other people might make mistakes. And so what happens if these arguments really are the wrong types? So, for example, if I call this thing invoke dynamic and I call it on the get method of linked list that takes an int, and I actually pass in an object. Well, that's really cool because this gives me a way to basically convert a pointer into an integer. Except that wasn't really the intent. And this is another one of the beautiful properties of these VMs that are built around these verification schemes, that once the verification scheme is violated, you're back to C-land, and you can turn everything into a rubble of bits because there's nothing, the type checker is your last and only defense. And if it's perfect, that's all fine. And if, as I have noted, people make mistakes, and they have, then, you get these little security incidents and things. And it's not really pleasant. Because, once you lose your type safety, you lose your memory safety, it's completely gone. Which is why it's basically a fundamental architectural mistake to put it in the heart of your system. But that's another talk, which I'm not going to get into here. I don't know if any of you were at Fool in January. I actually did give that talk. But I'm not sure my lords and masters approve. But anyway. So what would we do here? Basically, the instruction, that's where it's not just a change in the type rule. It has to dynamically cast the arguments to the types declared in the method descriptor so that if, in fact, you pass the wrong type, it'll fail dynamically. Now, fortunately, most of the time, this doesn't impose much overhead because the place I'm interested in using this most is in the code of the dynamically typed languages, where I expect pretty much everything will be an object or boxed into an object. And if it's of type object, which is all I really know most of the time, well, I know that it's an object. I don't really have to do the cast. And so that overhead is mostly optimized away. Where it's useful is for cases like this, where I'm calling into the existing Java APIs. Because those APIs have been compiled and optimized on the assumption that everything is statically typed, and they've been, compiled in such a way that is very efficient, but also very brittle. And if you pass them actually the wrong thing, they'll turn into a rubble of bits. And so in order to let you use this instruction and call into an existing typed API, you have to do the type check dynamically at some point. Okay, so this, of course, is only part of the problem. Again, I mentioned calling Java platform libraries, and that's one of the big reasons for doing this, because these platforms, your platform certainly, and even ours, have tons and tons of libraries and code and stuff, and that's one of the reasons to use them. In fact, it's probably the only reason I can think of to use them, is that they have a lot of this functionality. And so there are other issues. In particular, what do you do about overloading? And overloading, I mean type-based overloading, as you know and love from these kinds of languages. Again, this is one of the evils of static typing, is that it lets you do this thing, because overloading is just a horrible abomination. And it all only introduces problems everywhere you go. In particular, let's take this case. We have someone who likes to eat, and they can eat junk food. That's probably the common case. They can eat fish, and they have this special case when they have to eat. If they eat a thin mint, they get an error and they explode. And I don't know how many people know the reference, but and again, the damn thing isn't. Maybe I should. Anyway, But this is from Monty Python's The Meaning of Life. There's a guy there who goes into a nursery. He has a slight weight problem, and eventually he gets a thin mint and explodes. And if you haven't seen it, by all means, but don't blame me. It is the most disgusting thing I've ever seen on a movie screen, but it's a great movie. Anyway, so there. You can't complain you don't get value out of this talk, regardless of the technical content. So, what do we do in this case when we actually call this from a dynamically typed setting? So, I get some value from some method. I mean, var is nice if you actually you can infer types if you're calling a constructor, but if you're calling some method that doesn't declare anything about its type, you don't know what it's returning, and you have no clue what f is. And then you're supposed to basically pass it as an argument to the eat on one of these gourmand objects. And which one do you mean? And if you arrange your language nicely, there's no such thing as type-based overloading. Arity-based overloading, by the way, as in, say, Erlang, is fine. But type-based overloading introduces no end of software engineering problems, and as a language designer, you find that almost any feature you try to add also comes in. So you don't know, basically, statically. You can't compile this into the right call. You don't really know. Now, you can put in some weird mechanism into your scripting language for external calls where you force them to specify what types they think. That's rather gross. It's a possibility. But the tempting thing to do is say, well, let's resolve this at runtime. So even though the semantics of these methods are that they are in Java or in C# statically resolved based on the types, since you don't have any static types, you can look at the dynamic types of the objects and see if that helps you resolve things. So, for example, if it turns out that f actually is an instance of some fish type, then you're going to call the eatFish method, and this has to be done at runtime. And there's certainly people who want us to do this in the VM. I think it's too complex and brittle to put in the VM. If you care to look at the specification of method overloading in Java, I'm sure it's much simpler in C#, but sure. The idea of putting this into the VM, you don't want to put very complicated stuff into VMs like that. And it's brittle, because every time a new feature gets added to the language, typically something in overloading will have to change. Almost, not every time, but in a lot of cases. Anything systemic, anything that affects the type system or calls or things like vargs, all kinds of features have interacted in complex ways with overloading. So, God, I didn't fix this slide. This isn't supposed to say object. It's supposed to say some sort of fake type. But anyway, the idea is the same. You compile eatf into an invoke dynamic on gourmand, and you put in a signature that basically you know it's not going to have. That's why object is wrong, because it might actually have a version that does have object. In this example, it didn't. But as a general solution, you have to put in some fake name here for a type that you know can't exist in userland. Then you don't get an exact match, and then you can trap. This is for people who are familiar with Smalltalk's method not understood mechanism. This is inspired by it. And the whole thing, of course, is everything I do is inspired by Smalltalk, because, you can't really do much better. So this is a little more complicated, of course, than Smalltalk for the obvious reasons. You can't do anything simple in these platforms. But the idea is that when you get what would ordinarily be a no such method error, when the regular lookup fails, instead of just throwing this exception, it traps to a special handler that is a hook for users, or rather compiler writers, to put in special stuff that helps make this more general. So basically, when you go to this handler, you expect to get some sort of reflective descriptor that will tell you about the call site. Tell you which class it was, which method, what the bytecode offset perhaps in that method was, and an array of the arguments, and the method descriptor in particular that was used at that call site. So then you know what the type of this thing, whether you know all the information you would need to know pretty much to implement most lookup algorithms that I can think of, however perverse they may be. In particular, you could implement the whole Java, overload thing, and then resolve to that. And we hope to have a mechanism where we can cache the results. And that's rather vague and hand-wavy at the moment. I do like to leave something for the expert group to do before I start these things. So we hope that to put up a mechanism whereby once you've done this resolution and you want to cache it based on the types of these arguments or something, you can do that so that you can make you don't have to go through this process dynamically every time. This is still only a partial solution. There's all kinds of things in these languages with multiple inheritance. Not too many of them have multiple dispatch yet, thank God. Give them time. But generally, once you get into this whole multiple inheritance business, things become hard because there is one single inheritance everybody knows how to do. There's an accepted standard way of doing it, more or less, modulo all the gotchas with privacy and packages and things. But essentially, people know how to do that. Multiple inheritance, every language has slightly different rules, and it's very hard to accommodate them all with a single mechanism. Now, there have been various proposals for more complicated schemes, and I don't like complicated stuff. So OMDB is an acronym. It stands for Over My Dead Body. So I don't expect to go with anything very complicated. So about the multiple inheritance thing, however, again, let's assume for a moment, make a simplifying assumption and say that, let's assume that these things don't actually change on the fly. Suppose you could assume that a class was the class that it was declared to be and hasn't mutated as you loaded it or all these strange things that happened there. Then you could probably do a lot with invoke dynamic as it is, because you could encode many of these multiple inheritance schemes by linearizing the multiple inheritance hierarchy and doing a single lookup or things like that. If it's depth first, you can have several of these and do a series of invoke dynamic. There's various tricks you can do, but the problem is that things might change, so we'll get to that. But generally, it's a relatively simple primitive that's fairly flexible and helps with a lot of scenarios. For example, in Ruby, basically, again, modulo the fact that things change as you basically compile or run the program, it dynamically imports stuff and changes stuff. But essentially, it's mix-in based inheritance, and you can do it in a straight line, single path, like signal inheritance, once you know what the mix-ins are. And so that can help you a lot to actually do use the built-in dispatch of the VM. And if you can use the VM's built-in dispatch, it's likely to be a lot better than most of these scripting language implementations. So the problem is, of course, that all this made the happy assumption that things don't change. But they're called dynamical programming languages for a reason. And I don't like that term because, of course, to me, a static language is something like hieroglyphics. Nothing. It doesn't change. A dead language is a static language. But the dynamic languages are A, dynamically typed, and B, things mutate. The programs tend to mutate while they're executing. And, of course, this all comes from very nice ancient times. And the current crop of languages does this in much less structured ways. But nevertheless, there is this fact that things change on you, and that's what hot swapping support is supposed to help with. And it's very good because it's enormously cool that you can do that. The fact that you can change your program dynamically in this way, it's very useful for programming environments. You can fix stuff and continue it's very easy to implement really cool debuggers and environments that lets you modify things while you're running and see what happens without restarting anything. It's useful for all kinds of code that has to dynamically adapt to conditions. Once you get thinking this way, you think nothing of changing the class of things on the fly, and you can do state machines. You can do all kinds of cool things. And basically, once you use it, you become addicted. And if you ever go from using something like this, like in Smalltalk, and go to a world where you can't do this, you realize what a piece of it's really the coolest thing in programming, and people who haven't used it don't realize what they're missing. So it would be good to make some progress on this front. Current JVMs have very limited support. There's a thing called JVMTI, which is a tracing interface or something. And the way it's specified, actually, in theory, you could get a full implementation of most hot swapping functionality. Since we have to cope with this nasty problem that multiple people might implement our VM, we couldn't get everybody to commit to a certain level of functionality. And so the thing actually has an API that tells you, how much of the possible functionality am I implementing? Can I change method signatures? Can I change the shape of objects, etc.? In practice, the only thing that anyone has implemented is the ability to change the bodies of methods. So you can change the bytecodes in a method, because that's what they really needed in the short term. They needed to do tracing and breakpoints and things like that, where you just need to modify the bytecode inside a method, but you're not really changing the structure of the program at a higher level. The problem is that you can't even rely on that, because it isn't really a part of the platform standard, as it were. It's something that a lot of VMs do, but if you really want to be portable, and that's sort of the reason to write Java, then you can't really be sure that it'll be there. And it certainly will, in practice, won't support all the higher level functionality that it talks about. So you can't change the signature of a method. You can't really add a method, let alone remove a method. You certainly can't do schema changes where you change the shape of an object by changing which instance variables it has, and expect, you change the definition of a class by changing that, and all the objects, what happens to them in systems I know and love, they change. Their classes changed and they get rearranged accordingly. If you control the garbage collector, you control the garbage. That's the key thing here. So it can't do all these things. You certainly can't change the class hierarchy, which change what the superclass of a given class is, or rearrange it on the fly, which would wreak havoc with a nominal type system in particular. So basically, most of these things you can't do. Not coincidentally, you generally don't find any of these features in statically programming language environments and implementations. There's been a bit in research. But I think the earliest was a thing called Trellis Owl in the mid-'80s out of DEC Research. But generally, there haven't been many environments that cope with this, because it's hard, it's complicated, and costly. Now, costly is, of course, a relative term. If you have unlimited resources, you usually don't care about costly. So there might be people here who are not interested in the fact that it's costly to implement. You just throw an army, the third division of programmers, and eventually they'll make it work. But you might be late, because it's very complicated. And you have to trade off something. It either costs you a lot in time, or it costs you a lot in space, or something in between. There's sort of the no-brainer solution is to say, every time I make one of these changes, I'll just retype check the entire system, or re-verify all the code that's loaded. This has rather nasty properties in terms of time and interactivity and so forth. Generally, when languages have had this feature, it's been done in development, right? It's been done for IDEs, and if you have a big and bloated enough IDE, you can stick in all the machinery to do this. And, machines are fast now, and again, you don't really typically do this by retype checking all your code. You do it incrementally, and then you trade off space and complexity against time. So the finer grain your dependencies are, the faster this will be, and the more space these dependencies will take, and the more brittle it'll all be. And you can do variations, and the faster the machines are, the easier it is to get away with this. So you can imagine doing this in a big bloated IDE like the ones you've gotten used to. And this isn't just a snipe at Microsoft's products. Our IDEs are, if anything, more big and bloated. So just to avoid any misinterpretation there. But what if you have to do, if this is a feature that you want in the runtime, because these scripting languages are used to do stuff that's really dynamic, that you can do cool stuff in deployed applications. If their whole semantics of how you start up a program involves sucking in new modules on the fly as you go about and building up, as is the case in several of these, in Ruby and Python and so forth, then you can't just say it's a development time only thing. And so this is a burden that your runtime will take into deployment. And if your runtime is supposed to work on cell phones, then it gets really, really challenging to figure out how to do all this stuff incrementally. In other words, I don't think you want to do that. So what will JSR 292 do? Again, I don't like the promise people stuff. It always gets me in trouble. So we're not making any particular commitment about that. Invoke dynamic is really easy to do, so we're willing to say yes, no problem. Hot swapping, it's unclear how much we'll do and when and so forth. We'll have to see how it goes. The likely path, I think, is that we will enable hot swapping for dynamically typed languages, but not for the statically typed ones. Because the beauty of the dynamically typed languages is that they cope with change inherently. They don't have a brittle type system that has to be re-examined every time something changes, and so you don't need to maintain this complicated machinery. So one way you might do this, we have this notion of a class file, and we imagine compiling these languages into bytecodes, which are stored in class files. Doesn't mean file, really. It's just a bad name. It's a binary format for the JVM. And we could have a bit on these saying they're hot swappable. So any compiler for one of these dynamic languages would set that bit. Now, once we have that bit, when we do our dynamic linking, we can look at that bit and say, well, if it's a hot swappable class, we're not going to let you refer to it except in a safe way. So, for example, we have a bunch of bytecodes that are fairly brittle and intrusive, like get field and put field and all these invokes that rely on the types. So we're not going to let you use any of these. We'll say the only thing you can do with an object that belongs to a hot swappable class is to call invoke dynamic on it. That way, when you call it, everything gets checked dynamically, and if it turns out that your program, in fact, does not support the things because you made a mistake and it isn't actually type safe, you'll get, a dynamic failure, no such method error or whatever trap your language supports, which is what you'd get anyway in these languages. Yeah.
Why isn't Java hot swappable today? You can write class loaders today and do this.
Okay. So the question was, why isn't it true that you can do hot swapping in Java today, essentially using class loaders? And what you do with class loaders is you get a different version of a class. And situations where people need to do that occurs a lot, for example, in the telecom industry. A lot of them were raised on Erlang and didn't know they weren't allowed to do these things. And they have these switches that are supposed to work forever and not come down because people, living in northern Sweden don't like their phone service shut down because, you need to patch. They don't like phone switches being rebooted. And so they have these bad habits that they got from a system that was designed to do that. And they come asking for this. And we tell them, yeah, use class loaders. So in certain circumstances, you can get away with stopping, slowly winding down the old version of what you're doing and starting a new process that'll create new instances. So a class loader gives you a new set of classes that are different classes that may have arbitrary changes. They may have no relation to the older than principle. And you can start creating objects for those, and maybe you have something that has a thread pool and you start up new threads that will use those. And in certain scenarios, that does work. It doesn't work if you actually want to change the stuff that's actually there. You can't change the class of an object. You can't change what its class is, and you can't change that means two things. You can't actually replace the class of an object with a different class, and you cannot modify the class that an object has. So you cannot actually make these kind of changes where the actual live program is being modified, which is exactly what people do all the time in these scripting languages. And generally, class loaders are really hard to work with. And you can, yeah.
It seems extremely hard to provide any kind. It seems very difficult to provide any kind of typed account if you really are. Yes, that's what the scripting languages do. That doesn't mean that's necessarily what they want to do. It's the mechanism that's available to them.
Okay, so Shriram was saying that at least two things. One is that it's very difficult to provide any typed account of this, and in fact it's very difficult to provide any kind of account, untyped even, semantically consistent of what this is doing. And that's certainly true. And I would argue that a lot of people don't care, because it is very difficult to do what you want to do if you have to provide a typed account for it every step of the way. And the fact is they do it. Now, the other part that Sriram said is, well, maybe this isn't necessarily what they want to do, it's what they know how to do. And yes, I perfectly agree. I've always wanted the DWIM button. Do what I mean. And I want it to be correct as well. Even whatever I mean, it somehow has to be correct. If the laws of physics have to be modified for that, so be it. But in practice, we don't have a clue how to do the sort of things they do while maintaining all the nice semantic guarantees that Sriram wants, which are the subtext of this question.
Were you planning to answer either of my questions?
I believe I've answered both, but perhaps you think differently, right? You did say it's difficult to have a any kind of type guarantee. I agree with you. Your other question, none of them were actually questions, were they? But they were statements, one of which I agree with, and the other is, well, maybe they mean something different, and you know better what they mean. And possibly you do, but they don't agree with you. I don't agree with you either, for that matter. I think there's a lot of stuff that you want to do that involves these kind of changes, and waiting for you to understand exactly what the rules are so that you can prove every inch of the way, that's completely unrealistic. And people who want to do that, by all means, should provide a theory which accounts for these kinds of things, and it is very difficult. And the minute they have such a theory, I will be thrilled to hear about it. This is very sort of pragmatic stuff, right? There's this groundswell of interest in scripting languages out there. It's a grassroots mechanism, and people expect to use it, and I expect it to be much more important in the next few years. For a variety of reasons. And if mainstream platforms are going to keep up with this, they're going to have to support it.
So what you say is that actually there is no actual formal definition of all these things.
Formal definition, wow. There's no actual formal definition of the mainstream platforms today. There is at best a pile of natural language sitting in a book somewhere for one of them, and rather vaguer things for another. So now, formal definitions are very hard to come by, right? So John and Susie at one point did a formal definition for Modula 2, was it? Yes? A language that was a lot simpler than some of these things. And no one used that formal definition for a very good reason, because they couldn't carry it around. They got back problems. Formal definitions are really hard. So you probably don't mean quite that strictly, but is it well specified for some vague notion of well? You can specify what it does. You can say, yes, at this point, all instances of the class that you modified, from now on, if you call the foo method on them, will invoke the new ones. And then you'll have to worry about, gee, what about the ones that already have stack frames on the call stack? And the systems historically have had different answers to them. And it's true, most of the systems that have done this never bothered to specify squat. They were too busy doing stuff. But it would be, we generally do try to specify it at some level what it does. So we would try and answer these questions. What happens so when you change a class and add an instance variable, well, what does that mean? Is that a new class and from now on the constructor will produce these? Or what happened to the old objects that haven't been collected yet, that are alive? Are they, so the typical answer is, yes, we'll change them. You can do that with garbage collection. You can actually make them all have the new fields. And there's various tricks you can do to do that at varying costs. So you can probably specify that, as opposed to formal, which no, I don't. I think it's very difficult. Now the real hard question is, of course, suppose you have an application that's doing this. Well, what does it mean to have, what does the application mean if it's changed, and now maybe it's partly in the state brought about by the old program, and now I have the new program. And that can be very tricky. And in a lot of cases, you do want to structure it such that you're replacing, old instances you're adding new things, and the new stuff starts, which is what actually happens both in Erlang and with class loaders. And in some cases, you don't. But I find, for better or worse, most people don't expect to have a very good specification of what their program is doing. They'd like to, but they'll never be bothered, right? So I think, and especially if you look at the world that this is coming from, at Perl to take the bottom element, your concerns are not foreign to them; they're alien to them. Yeah. So, but there are a lot of cool things you can do, and it's very hard to argue with cool. There's a lot of stuff you can do, and it's good to have that functionality. And if you don't want to use it, by all means, prove your programs correct. Far be it from me to discourage you from doing that, unless I'm paying for them. So anyway, we don't have that much time and not too many things to say either. So, as I said, we're not committing to anything. Maybe we can do a bit better. By better, I mean that, maybe we'll actually be able to get some of these features to work for Java programs. I mean, it is possible to do this in a statically typed context. It's just very much more complicated to do that. So you can verify that you've made this change, and yet the resulting system is, again, type consistent. There's pros and cons to that, and I don't know of a way that I would consider plausible at acceptable cost for Java and the various contexts it has to run in. But, maybe we'll get inspired. And even this is still only a partial solution. We haven't still done anything directly for multiple inheritance or multiple dispatch, but if you have these two, you can work out something that'll work, but it's still quite complicated for the implementers of these systems, but it's not nearly as bad as what they have to go through today. Actually, mix-in-based inheritance is a very good general-purpose primitive that helps address this, because then again, you can usually linearize without copying the definitions if you have mix-ins supported in your VM in a reasonable way. We did that in Strongtalk many years ago. Actually, .NET is better positioned to do that than we are because Andrew Kennedy's work and Don Syme's work on generics actually lets them define a form of mix-in as well. I don't expect us to actually do anything about this in this current incarnation of 292. We haven't talked about doing anything to help with closures. That would be a very nice thing to do. We might. Again, it's up in the air and lots of discussion about it. You can manage fairly reasonably without it, but it is ugly. The handling of non-local returns in particular requires these horrible exception schemes, and if the functions are recursive, it gets worse. But it can be done, and so it's not absolutely essential to have the VM support closures, but it would be nice. And we haven't really done much in that area or even given it much thought. But if you had those four things, then I think you're getting somewhere. Various links to where you might find more information about this in the unlikely event you're actually interested. And to sort of conclude the actual talk, Sun actually now does want to see, of course we always wanted to see, but now we really want to see, a variety of languages running on the Java platform, and in particular dynamically typed languages, because they really are, they're in a different niche. That's actually a mistake, by the way, because they start in a different niche, and it's a disruptive technology, and eventually it will eat you up in your niche. But that's a different talk as well. So we are trying to improve support. JavaScript is shipping in Mustang. Groovy, I don't know what they're up to actually, but there are these things. JSR 292 is trying to, rather than add actual languages, is adding infrastructure that will make it easier to implement languages and implement them well on the Java platform. And finally, again, the relevant, go back, and the screen is too small, but another Pinky and the Brain little scene that I found is dynamic languages plan to take over the world. And I actually think they have a fairly good chance of doing that. But that's, again, a different talk. So if there are any further questions, complaints, whatever, let me know. Well, oh yes, continuations. So continuations are, yeah. So well, stack control has lots of issues. I mean, if you make that general enough, right? Security issues, etc. Continuations. Some of these languages have continuations. Some of them are in a hurry to add them because they evolve very fast and they're very responsive to relatively short-term trends. And so Ruby has declared that they're adding continuations, and I don't know at what stage they are, but it didn't have continuations in the beginning. I have whoever asked this question knows what my take is that continuations in general are kind of a really cool thing, but of fairly peripheral value. They're currently very, very fashionable for doing web-based stuff because they help you capture the context in this kind of he said, she said conversation that you have over the web. My take on that, and Sriram will no doubt have a lot to say about this later this afternoon, and we can have a nice argument there. But my take on that is a temporary thing, because ultimately the he said, she said dialogue will go away. Ajax is a precursor of that, where you basically get applications downloaded through your web browser, and you don't keep going, going through the sequential dialogue of going from one page to another to give information, get information. And in that model, you don't need the continuations that much, especially if those applications grow to be serious things that cache their data and have mechanisms that support that. So again, that's a whole other talk, really. But I think the continuations on the web are currently very valuable, but this will pass. And consequently, I'm not too interested in them beyond their beauty as a computer science kind of construct. But as a practical thing, they're not high on my list, and they're a nightmare to do on a thing like a JVM, and we're not doing them, which was really the point of my my post, which is, in your system, you're welcome to have continuations. I don't think they're something that you want for the long term or need. I say want is fine. It's cool, right? But you don't necessarily need them for the long term. You need them right now to do sort of the kind of lame web dialogues. But that's an artifact of the really bad structure of HTML and HTTP right now. So maybe I answered that.
Do you see the connection between hotspot and hot swapping? Any same kind of
well, they both come from the same place, really. Right? The precursor of a hotspot was the self. Well, first the anamorphic Smalltalk VM, Strongtalk, and before that the self VM, both of which pioneered the techniques that are used in hotspot and dealt with dynamic update in all these forms. And so, once you're used to thinking of that model, you tend to think of compilation as a more dynamic thing, or the fact that you have to adapt. And sometimes some of the mechanisms are similar, because when you're doing sort of hotspot style compilation, you do inlining, and then the definitions change on you, and you already have some of these dependency mechanisms in there. So there's all kinds of probably technical connections, but I don't see this as necessarily tied. I mean, if you're doing a system which is really trying to compile in a traditional form, you probably find that all kinds of things are much harder to do in this vein. But I'm not sure if it's essential. Yeah?
The JavaScript implementation you mentioned, does it use any of this stuff?
Is JavaScript on the JVM, you mean? It's basically an interpreter on. No, it's not, none of this exists. Okay, I traffic in vaporware like many people in this industry. This is what we're going to do. JSR 292 is this committee that will go off and with some luck we'll ship this in Dolphin, which is the next release. So that's whatever 2008 or something. No one really knows, right? We're about to ship Mustang, which is toward the end of sometime this year, and so we're just starting on the next release, as it were. So it can't use it. It doesn't exist. It's just it's doing the stuff that everybody else has done, sort of building on an interpretive framework on top.
Is it based on Netscape?
Yeah. The question was whether it was based on Rhino, and the answer is yes. Okay. Thank you very much.